Okay, so just a few quick things about the exam. Your scores will look different, and somebody told me that they still couldn't see the second exams posted. I've already pushed them through, and they're on Moodle on my end. I have no idea why you wouldn't be able to see them. You should, as far as I'm aware. Oh, like the grade you got? You're gonna have to come catch me like sometime during lab, because I don't have a way to push out everybody's score. I can just give you the grade, I guess, is all you can see. But you're more than welcome to ask me and I'll share that with you. I don't mean to keep it a secret. It's just the way it's set up, I guess. So I'll go through and correct ones that you might have put the different word in and different spelling, and then I'll push those grades out to Moodle. So your grades will look different probably than your review. Yeah? Yeah.
Do you know how you're going to be grading for like a word that is made of two words, but we got the second word wrong? Like let's say incisive foramen, you did write something else instead of foramen?
It depends on how wrong. So like if you call it like the nasal spine and it was the nasal septum, just the word nasal won't get you through. But on another one, like if you write maxillary, like, you know, like if you say orbit and then you add a word or something like that, I'll give it to you because there's only one orbit. So at least you knew it was an orbit, but maybe you were just panicking and trying to add something. So it really depends on what it is. Like if I feel like you really didn't know what the structure was, I'll give you the point. But if I feel like it just kind of happened out of chance, then so it's, and if you have, again, like you can always come with me, we can go over it in my office if you feel like, you know, you want to talk about it. But so it's going to be probably more specific. Like it would have to make sense. You know what I mean? Yeah. So it'll kind of be case by case. Yeah.
Do you know when you'll have those on?
Probably tomorrow morning because I have lab in the afternoon. Okay, so I'm going to jump into this lecture so we can get through it. Like I said, I'm just going to go through this. It's a little bit of a complicated sort of brain thought, so because you have to kind of visualize things. So it's okay if you just kind of passively listen and absorb as much as you can. And then in lab, when I have your table group, we'll go over it. And like, I'll probably repeat a lot of the key features because I know you guys, your brains are probably like as full as you possibly can be after your days of lecture and then your exam. So just kind of passively absorb it as best as you can. Yes, Ryan. You can just keep it or throw it away or whatever. So the objectives for this are to state reasons for using this thing called localization technique. So why do we even need to use it? So we'll talk about that for a minute. Explain the principles of the Buccal object rule. So you kind of have to eventually be able to explain what the Buccal object rule is, how it works. Identify clues to determine angulation change when given two similar radiographs. So when you look at a radiograph that is of a canine, and then you take another shot of a canine, but the angles have changed, either horizontal or vertical, what are the clues that tell you which direction it changed? So that's what we're looking for. Use principles of the Buccal object rule to identify the location of a foreign object using radiographs. So if there's something in there and you want to know if it's more buccally oriented or more lingually, or is it even in the bone, or is it in the soft tissue? Maybe it's something that's in the cheek and it's not even in the bone. This kind of helps you figure out where it possibly could be. So that's the point. And I had one other thing to say. Oh, I know. The other thing that this is called, and it's actually called this more often, is called the Slob Rule, S-L-O-B. Don't look it up. Don't look it up. It'll just confuse you because this is basically, it's the absolute opposite of the Slob Rule. So when you go online, if you really think this is fun and interesting, you can go online and see some videos. But if you're struggling with the concept, I don't know if you should go and look it up because it might just totally throw you for a loop. So but people teach it two different ways. They teach it Buccal object or lingual, basically. Slob is same lingual object buccal, whatever, opposite, you know, whatever, anyways. We're not even gonna go there. Just don't look it up is my big take home thing for right now. So why do we use the buccal object rule? So like I said, you might have a tooth that's impacted, and you might want to know if which direction the roots are. Are they kind of going buccal? Are they going lingual? You might have a root canal you might have a bifurcated premolar, and there's two roots that have been had a root canal. And you might want to know if you're looking at the buccal or the lingual root. You might have an impacted third molar, and the dentist, or down here, see how close the roots look to the mandibular canal. Are they on top of the mandibular canal? Are they buccal? Are they lingual? Are they, are they straddling it? And so this is a method of kind of orienting yourself a little bit and figuring out how something is positioned in the mouth. Okay, so this is just the reasons why. So endodontic treatment, foreign bodies, if you break an instrument tip and you want to figure out, did I break it more, in the more buccal, the distal line angle, more buccally or more lingually? Who knows? I'm just coming up with different ideas of what, for why you might need it. So different foreign bodies, impacted teeth or unerupted teeth. I'm just going to go through these slides kind of methodically because it's a little bit to wrap your brain around. So if you have two similar images at different vertical or horizontal angulations, and you apply this rule of projection, you're going to be able to hopefully determine where the object is that you're looking. So in this film, we're noticing that there's kind of a radiolucent thing here. Looks like a little supernumerary tooth, and you can see it here. So we're going to look at these two films, and we're going to try and determine if it's more buccal or more lingual. And so that's what it means by taking two different films and kind of comparing them based on the change of your vertical or horizontal angulation change. So when two different radiographs, this is the buccal object rule. It's a total mouthful. So just kind of absorb it for a minute and we can break it down. We can try and understand it a little better in lab. But the basic rule says when you have two different radiographs that are made of a pair of objects, the image of the buccal object, so the one where the object is more buccal, moves relative to the image that's the lingual object in the same direction as your beam. So your buccal object is always going to move in the direction of your beam, meaning if your beam goes mesial, your buccal object goes mesial. If you turn your beam distal of your BID and it goes distal, your buccal object, just the buccal object, will go distal. If you go up for a vertical angulation, it'll go up, down, it'll go down. So that means that so you're following the buccal object goes in the same direction as your beam. Sounds kind of simple so far, maybe, right? Maybe, maybe not. Okay, so here, this is showing, in this diagram, you have a tube head, so you have a BID, and you have a change in your position of your BID, but you don't have a change in the angle of your central beam. So you just moved from here to over here. So you just moved laterally or sideways, but the beam didn't move this way. So the object, if there was something that we were trying to identify, it just stayed pretty much in the same position, even though you moved your BID maybe more distally, but you didn't move the horizontal angulation, you only moved the BID itself. So you just moved in this kind of position, not like this. Does that make sense? So moving the tube head without changing the beam direction would result in a cone cut, right? You'd lose some of the coverage of your sensor, but you wouldn't change the vertical angulation, and so the object wouldn't move with it. However, if you direct the beam mesially or distally, this will result in the movement of the object. So here we have an object, and then the beam, you can see now it's coming at an angle. This is demonstrating like your central rays coming out of your BID. So it went from sort of straight through the contacts to moving a little bit more mesially. So your object here, which is this kind of target, it moved from over this mesial buccal root to more over the palatal root. So when this beam got moved mesial, the object went distal. Yeah. Yes, I am recording. Yes. And we'll talk about it in lab too, but I am recording. So in the diagram below, the X-ray beam is directed more mesially compared to the first X-ray. So remember, we're always going to compare two X-rays, and the object of interest located lingual to the first molar moves distally in the opposite movement of the beam. So you have to have actual horizontal movement. Yeah, Tala.
So because why are we location and then
Yeah, so the question is like, why would we, or how are we comparing it, or what, maybe what's the purpose, or how would we apply this? You would need two images. So you would take, say you take a bite wing and say it's really straight on and you open the contacts. And so you got a really nice horizontal angulation and you notice some kind of a foreign object in that picture. And then you might go, I wonder where that is in the picture. Like, where is this located in their mouth? So the first one, you can call it sort of like your baseline, because you know you took a really nice picture, it's straight on. So then the next one, you could move your BID, you could change your horizontal angulation, and then you would look at those two images, the one that was straight on and the one where you changed your angle, and you could look to see where that object moved. Yeah. Jenny? So yeah, the question is it only horizontal? It'll apply to vertical as well. We just haven't gotten there yet. But yeah, it applies to vertical. Okay. So in moving from the incisor film, so when your BID is in the front of the patient's mouth, in moving from the incisor film to the canine, from the canine to the premolar to bite wing, your BID is essentially moving more mesial. It's moving more mesial. And so the central ray coming out of your BID is more mesial each time. So that knowing that kind of helps you, because sometimes you'll just see one picture. And then when you go to take another one, you're like, well, I don't know exactly how they took this picture. But you know that in general, it's directed more mesial as it goes. So you could purposefully go more distal and then see how it changes. But that's just sort of the typical way that the BID goes as you come around the arch, is it goes more mesial. Okay, so here's just kind of reiterating the same point. In the diagram at the left over here, the buccal object, which is the yellow object, and then the lingual object, which is the red triangle, they're superimposed over each other because you've come in at a really nice perpendicular angle. So the sensor's there, and then it's like coming right through and taking both objects and superimposing them on each other. Both of them, and they are the same relative position mesiodistally and vertically. So they're kind of like right in front of each other, sort of. Both images are located above the second molar. So kind of like right above the palatal root, above the second molar. And they're just superimposed for the way that first picture was taken. So then the second picture, if you change your horizontal angulation and you turn your BID more mesial. So in the diagram at the left, the beam is directed more mesially. On the radiograph, the buccal object, which is the yellow one, moves mesially in the same direction as your beam in relation to the second molar and the lingual object, which kind of went in the opposite direction. It didn't move as drastically, but it did move more distally. So then this is showing what it would look like on an X-ray. You'd go from, can't get over here very good. You'd go from them both being over the palatal root to the buccal object going more over the mesial root, and then the lingual object going a little bit more distal. So the buccal object is just tracking with the direction of your central ray, and your central ray went mesial, so the buccal object went mesial with it. Horizontal movement. So in the diagram at the right, the beam is directed distally. So then the opposite happened, but it's the same thing. It's tracking with the beam going distal. So the buccal object moved distal. On the radiograph, the buccal object of interest moves distally, same direction as the beam in relation to the second molar, and the lingual object of interest moved mesially in relation to the second molar. Okay, we're not going to do demos. We're going to do that stuff in lab. So, clues to changes in radiographs. It seems like I'm but anyways, clues to changes in radiographs. So we're going to look at vertical and horizontal angle changes. And the things, there's certain structures in the face that are always going to be buccal. Can anybody think of some landmark like that you actually had to do on the exam today that's like a very buccal structure? External oblique ridge is a buccal structure, and I think I heard someone say zygomatic process. So yeah, like your most buccal structure is going to be your zygomatic process. Think of what because buccal is out here, right? Lingual is back there. So what are you coming to first? When you touch your face, you come to your zygomatic process first, but the external oblique ridge is also. So variation in root length, movement of cusps, your buccal. I don't know if, I think I've pointed out in lab several times, I've pointed out the buccal cusp for you guys just to start to kind of recognize. The buccal cusps are always going to be closest to the edge of the film. So you can always look and identify buccal cusps. So that's going to help because that's always going to be there. The zygomatic process is always a buccal structure, and your external oblique ridge is always a buccal structure. Those who went into dental assisting, did you guys remember this lecture at all? Did they cover this? You remember it?
They didn't cover it, but our doctor actually.
Your doctor talked about it? Yeah. I was wondering if that was covered or not. Yeah. You're like, it made no sense then. It makes no sense now. I'm like, I never used it. Why? It's really very cool. Like if you had the time to like do this in the office, I'm sure there's hygienists and assistants who have done it before, but I can't say I ever did it in practice, but that doesn't mean that it's not very useful. Okay, so horizontal, so HA is horizontal angulation. Change in, one thing you'll notice is a change in the root tilt. So the way the roots tilt. So roots tilt in the same direction as the beam is aimed. So this, in a very practical sense, I actually find this a little tricky. So I anticipate you guys might as well. It doesn't always seem as blaringly obvious as I wish it did, but this is something that we can use. So it works in all areas of the mouth. So this is a central picture taking straight on. This is picture obviously with the central ray going a little bit more distally, on this side, and the same thing here and here. So it kind of, they just sort of tilt in that direction. There's one at the end here, an example, and if you really look at it and think about it, it starts to make sense, but to me, it's not quite as obvious as I wish it would be. Buccal cusps, so the movement of buccal cusps. So buccal cusps are always closest to the edge of the film. So here's the edge of your film here, and this lower cusp is the buccal cusp, and this is really whited out. It's very hard to see. Maybe this is better, but see, this is your lingual cusps all through here. and then your buccal cusps are all stretched down. So you can see when you take the film straight on, look how the buccal cusps dropped down and moved distally. And here they dropped down and moved distally on this side. So on either side of the center, the midline, they moved distally. So that's actually quite helpful because it's a little bit more pronounced. I feel like it's a little bit more kind of like you can pick it up and see, because you can look at your lingual cusp and then see if your buccal cusp, on which side of your lingual cusp is your buccal cusp. So it gives you something a little bit easier to look at, I feel like. Lex? Yeah, so I wonder if I can. So here's the lingual all the way up here, and then the buccal is all the way down here. And you can kind of see how like your buccal is all kind of going off in this direction. So that's mesial. I'm sorry, it's because of the way they're put in the, this would be mesial because these are more anterior teeth. Sorry, I got that backwards. But so the buccal cusp is going more mesial. They're going in this direction. You should make a little arrow like this. You see that? And then the lingual cusp is up here. So that's very different from up here where you have about your lingual cusp and then your buccal cusp. They're closer together, see that? This is weird the way that these are set up. This is actually like backwards. So it's kind of confusing, but this is going distal and then this is going mesial. Yes, we will look at more. Okay, but you can use buccal cusps as a reference. So that's another thing that you can use as a reference. So horizontal angulation movement of buccal cusps. So here's kind of a live example. So objects are located buccal. Objects that are always located on the buccal side, they will move in the same direction as the beam. So that is something we can always have with us as something like if they're buccally located, they're always going to move with the beam. So we can always use that as sort of our grounding point, sort of. So on the bottom picture, the buccal cusp of the first premolar, this guy right here, it moved distal. You can kind of see this cusp here moved distal because here's your posterior teeth, right? So it moved distal to the lingual cusp compared to the baseline, which this is your baseline because this is a more straight on picture. So that's the other thing is we'll look at these pictures and we'll say, well, which one is our baseline? And you want your baseline to be kind of your truer perpendicular, kind of straight on. And the one that is sort of tilted one way or the other can be your comparative. So when we look at this first one here and we see the buccal cusp here, and then we compare it down here, we can see that the buccal cusp sort of shifted distally. So therefore, the second X-ray, the beam is directed distally. So then you know, because that buccal cusp tilts kind of distally, you know your beam got turned a little bit more in a horizontal angulation going distal. So then what it's asking, does that kind of settle well? You guys? Don't ask me why you need to know it. We're learning it and it's good information. Yeah. It'll just open the contact. Yeah. Well, that's a really practical, I mean, and that's actually very practical for day, because there's not going to be a time necessarily when you're identifying supernumerary teeth or the direction of roots for a nerve, but very practically, you could use it maybe to open up contacts. That makes a lot of sense. So that's a good example. So then this one is saying, this is which way did the object move? So then our object is here, the supernumerary tooth. We have the supernumerary tooth here. So it's kind of on the distal side. It's between the second and the second premolar and the first molar. And now, where did it move? Did it move more mesial or did it move more distal? It moved more mesial. So if we know that the beam moved distal and this supernumerary tooth moved mesial, and then is it more on the buccal surface or is it more lingual? It's more lingual. Good. Yeah, you guys are getting it. What's that? So remember, that's why I told you guys passively. I know I asked you a question. I asked you an active thinking question, but don't worry, I will repeat it, but don't worry, just let it kind of sink in and then we'll go over it in lab again too, which I'll can talk it through. But basically, so since we identified the buccal cusps, so we know here's our buccal cusp, and then we see how our buccal cusp moved distally, and we know buccal cusps move in the same direction as the beam. So the beam moved distal, the buccal cusp moved distal. So we have that going for us. We know that. And then what we can notice is that this supernumerary tooth moved from this sort of distal location between the premolar and the molar. And now it's hovering more over the premolar. So the supernumerary tooth shifted mesial, not in real life, but just in the image. It shifted mesial. So then, since that's opposite from the buccal, then from the direction of the beam, we know it's lingual, because it's the buccal object rule is that if the beam and the buccal object move in the same direction, so a lingual object will move in the opposite direction of the beam. Then it's lingual. Yeah. So you could say same buccal, opposite lingual. I don't know. Just never mind. If it's the same direction as the beam, it's buccal. And if the beam moved mesial and the object that you want to locate moved in the opposite direction, then it's lingual. Yeah, Anna. It's literally like the ray coming out of the BID. So it's the energy, the central ray, the particles of X-ray radiation that's coming out. It's the way that moves. So not necessarily the box, because if you notice, if your beam is moving mesial, when you go to move your beam, your box is going to move in the opposite direction. So don't think about the actual movement of your X-ray tube head. Think about the central ray of your beam coming out and the way it moves. Does that make sense? Okay, that throws people, because they look at the way they move the tube head and they think, well, the tube head moved, they mix it up. But think about, like, if you could make the central ray purple and it was like oh, you know what I wanted to bring? A laser pointer. Because not like I'd shoot it at you guys, but if I put it like on the wall and like not the direction of the pen, but the laser, like you have to focus on the actual laser coming out. Yeah, flashlights. Yeah. Yeah. So that Liddy, that's a great. So Liddy was just talking about sort of a shadow casting thing that you can do, where you can actually use a flashlight, and if the beam of the flashlight moves in the direction of like a buccal as relation to a lingual object, I can bring that stuff into lab, and we can actually do that in lab. And that does help a lot. You can do that at home. If you set up two things in front of like a white wall, and then take your flashlight, and then you just kind of move your beam, the thing that's buccal should move in the direction of your beam. It should work at home too. You could easily kind of do a little experiment. So that's a great recommendation. Okay. Yes, Jenny. We can, oh, you mean like in the actual like x-ray rooms? We might be able to, because next week we're going to do the piano proficiency, and then there's a little table time, which we're going to work on this, and then you had time to do partner placement. If you and your partner both agree you don't want to place on each other, then you could do some experimenting with the buccal object. But I would probably say if you feel like it's more important to place on each other, then you should probably use that time. But we certainly can, and there's another lab where we could practice that too. I think week 13, you guys will have time for that. But it's almost more like just getting the theory down, and then I have a worksheet too that will help too. We'll do that in lab. Okay. So what time is it? So angle change. So the top picture, the buccal lingual cusps of the first premolar, and then the bottom of the, so we have the top buccal lingual cusps of the first line up, they're kind of superimposed over each other. And then on the bottom, the buccal is more distal. So this is the same picture that we saw. And then, oh, this is just kind of talking it through. And then the supernumerary tooth moves mesial, it's opposite of the beam. So therefore it's lingual. So it's just talking about horizontal angulation movement of buccal roots. So now we're going to look at some buccal roots. So we know this only works in the maxilla because you have your two buccal roots and then you have a palatal root. And the palatal root is clearly lingual, right? Because it's behind the buccal, the first two buccal roots. So two buccal roots, one palatal. Buccal roots move in the direction of the beam. The beam is directed mesial, and then it's asking why. So how these two buccal roots, this one here, this one here, they're saying these are mesial. The beam was directed more mesial as compared to this baseline, and they're asking why. So can anybody kind of tell why that might be? Yeah, there is some difference in the size, but look at this space here. See this space between this buccal root and the palatal root, and there's no space, it's overlapped. So the root itself is farther away in the picture. It looks farther away from the palatal root. So it moved in a more mesial direction. So since it moved in a mesial direction, and you know buccal roots are buccal, it says it in the name, then you know that the beam moved buccal as well. That makes sense. So you look at your first, I don't know if my writing all over these pictures helps or not, but you look at your baseline, which is your truest picture that has like the nicest sort of least amount of distortion. And you look at that, and you can say, okay, here's my buccal roots that are sort of superimposed over this longer palatal root. And then in the next one that I want to compare, these buccal roots have shifted mesial. And I know this is mesial because this is posterior. This is my third molar, second molar, first molar. So they've shifted mesial as compared to this picture. So these are more straight over the palatal root. Now they've shifted mesial, and I have more space here. So I know that the beam was directed more mesial from that baseline image to the second image. So that's why I know. So it says beam directed more mesial, why? And that's how you can tell. Yes, what? No, go ahead. Well, so if we hearken back to the first slide, you like, why do you need it? You're asking why you need it. You're asking why you're learning this? Because that question was answered in the beginning of class. Okay. Okay. I know you're just tired of this long day. You'll find this thrilling and exciting when it comes to lab. I promise you. Okay. Yes.
I feel like this is where the past directed me to for that line, is it asking like why would it be directed usually, or like?
Oh, I think it's asking. Yes, I do think that that's what it's referring to is why do you know? Yeah. Is that what you were asking, Jenny? Yes, that's a perfectly good question. And yes, that is, I think that is why it says why. Is it's asking, why do you know that? How do you, I might have, if I'd written that slide, I might have said, how can you tell? Or how do you know? But I do believe that's what the why is for. Okay. So horizontal angulation movement of external oblique ridge. So now we have another structure that we know is buccal. And so we're going to identify it. It's the external. So it's the part of the ridge that's closest to the cheek or the front. And then we have our internal, which is more lingual. And then it comes down, down into the mylohyoid, like what we've been discussing for landmarks. So our external is going to be closer out here. It's going to be more buccal. And we can look in relation from this picture here, which is going to be our baseline because it's just sort of a more straight on picture. We're going to see where the external oblique ridge comes to about right close to the CEJ, not, it's actually the CEJ is down here, but it comes about maybe halfway up, I guess. So it comes right about halfway up the crown of the tooth. And then we look at this one and it's kind of on top of the tooth. The external oblique ridge is now like almost on the occlusal surface. So you can see that it's moved. It's gone from one place to another place when you compare the two films. So the bottom, the ridge crosses the distal of the second molar. So this is just basically what I was just saying. So the bottom one, it crosses distally here. The top, it's about in the middle of the molar. So now we're looking at this tooth here, which is our impacted third molar. So we're going to look at how it changed between those two pictures. So we look at this first one, and this kind of looks to us like it's the occlusal surface, right? Or it looks like the occlusal surface. But you want to notice the roots coming back here. Kind of want to notice the roots. And so they go from this position, kind of like, oh, my marker didn't work. It's probably going to show up in a second. There we go. So they go from here to here. So you see how the angle changes? Goes from this angle to that angle. And then our external oblique ridge went from here to here. So our external oblique ridge is buccal. Our external oblique ridge went from the baseline image to the second image more mesially. So we know the beam went more mesially. And then the direction of the roots from that same first baseline picture to the second also went more mesially. So do you think the roots are pointing lingually or pointing buccally? So, okay, hold on. Let me erase this and then we'll walk it through one more time. So we have our external oblique ridge here, which is our buccal landmark. We know it's always going to be buccal. So we have our buccal landmark, and then we have that it moved mesial. And the way you can tell it's mesial is because from this point here to this point here, oops, that's a funny line. But if you draw it on this same picture, if we traveled in this direction to get here, did I just go mesial or distal? I went mesial, and well, hold on. So the external oblique ridge went from down here to up here, essentially, in the second picture. So the external oblique ridge moved mesial. So that means if a buccal object moved mesial, then I have to know that the beam moved mesial, because the beams and buccal objects move in the same direction. Yeah? Yeah, so that's kind of why I do these little funny scratchy things. So hold on. So I wish I had what you guys have. I wish I had like a tablet that I could draw on. But so the way I know that it moved mesial is because I have the external oblique ridge is here, right? You guys see that? It's right here. And then in the next picture, it's here, which if I am to draw it here, I'm just going to draw a line here because so it's going to be here. So these two lines represent the same thing, this one and this one. So in the second picture, it's gone all the way up to there. And so if I draw a line from here to here, which way am I going? Am I going mesial or am I going distal? Look, but look at like this. Okay, let's do this. Here's one line, here's another line. Is line number 2 mesial or distal to line number 1? Do you see what I mean? So this and this, one is more mesial. Does that make sense? Okay. So we're going to just keep moving through it. We're going to keep moving through it because I know it's not an easy concept to just get, and you're not being tested tomorrow on it. So we will talk about it more and I can show you like more in lab, but trust me, it's moving mesial. So, and we can talk about it more because I know what you mean. Like when you look at the picture, your interpretation, you can be looking at different things and it can definitely throw off your interpretation. So I understand where that frustration can be, and you just have to look at lots of pictures, and we will. And this is not an easy concept. Oh my goodness, this is like a mind twister. So don't worry, we're going to work through more of this before you can feel like you really understand it. So, but basically because Chloe. Oh, sorry, Lex, go ahead. The baseline. Yeah. I can't quite remember how. So Lex is asking if I'll be able to tell you which one is the baseline picture, like for an exam. And I think so. I don't see why not. But a trick is look for the one that sort of looks like there's the least amount of sort of distortion, or like the most straight on perpendicular shot. That's going to be your baseline. Like better, least distorted image is going to be your baseline. Okay. So for this one, we know that the roots moved in the same direction as the beam, so the roots are pointed out buccally, which is kind of funny because when you look at this, like just looking at this, don't you think like the occlusal surface is looking at you? So you'd be like, oh, so that's kind of just a good example of how it can be very deceptive, and this can help you identify the orientation of a tooth. Okay, moving on. So external oblique ridge versus the mandibular canal. The mandibular canal can be anywhere inside of the jaw. It doesn't have a necessarily, it's always buccal, it's always lingual. It's just inside, working its way down to the mental foramen, but its location, buccal or lingual, is not reliable. So you can't use the mandibular canal as a stable landmark, but you can use the external oblique ridge. No more practice. Okay, so now I think we have like 4 minutes. So we're gonna go over this more in lab, but you are gonna apply the same principle. I'm not gonna go through this as slowly because this is the same principle, but now we're talking up and down. So we're not talking right to left, mesial distal. We're talking vertical angulation. So the way your beam is pointing either up or pointing down. So I'm just going to kind of zoom through this a little bit. So this is the side of the tooth. Sorry, I'm looking for my mouse thing. So this is looking at the tooth. So this, like, let's say we're looking at the distal side of this premolar. So this is buccal and this is lingual. And if your vertical angulation is pointed more down, then the buccal object is going to be lower, lingual object is going to be higher. So it's going to move in the direction of the beam up and down. This just shows the opposite. You turn it up. And so now this is showing your zygomatic process, which is a very buccal landmark. And you can see how so this happens all the time. You guys have a really practical application because you just took your landmark exam. And sometimes you can see the zygomatic process and sometimes you can't. So it just depends on how, vertical or how flat they came in when they took the picture. So like this one, like a flatter angulation, the zygomatic process is actually sort of higher up. And when they pointed the vertical angulation much steeper and much more down, then the zygomatic arch stretches down over the teeth. So it kind of like, it projects it down lower over the roots, as opposed to this one that was more straight. And so the zygomatic arch looks higher up or farther above the apices of the roots. So here we have, I don't know if I have enough time. I do. So, okay, we're gonna end there because I know. There is a recording of this that I did last year. You guys can listen to that, but we will talk about this in lab. I'll sit there at the table and we'll talk all about it.